Welcome to the Spooky Action at a Distance television show. I'm your host, Kyle Finley, and this is the best show north, south, east, and west of the Rockies. And today we're going to be talking about the end of the universe, as so I hear it. And with my guest over here, Steve Snodgrass. How you doing, Steve?
Hi, Kyle. You know, I know I'm supposed to say I'm really doing great or I'm doing it enthusiastically, but today I have to admit to start off, I'm tired and I'm confused.
You're tired and confused.
I'm tired of thinking about physics and the end of the universe, and I'm confused because I work in human services and I don't have a degree in mathematics or physics or anything like that. But for the last 10 days straight, I've been trying to figure out what would be a way to talk about the end of the universe that's kind of different from whatever we see that there is on YouTube and Wikipedia and all the references that are there.
I mean, most of them, it seems to be like, you know, they talk about like multi-universe theory. They talk about, it's just all theoretical physics, so you don't have to worry so much about the math. Until you get to string theory, then it's like, it's nothing but math, so it's like, you know.
Right, and whatever you get anymore, we end up with, well, we know so much, and yet, what is the point? Where did we come from? Where is this all ending? What are we supposed to do when we're here? None of those questions that are kind of meaningful to me ever get answered. So,
why are they meaningful to you? Is it because you got a philosophy degree?
Well, that would be part of it, I suppose. But if I got to understand really the nature of the universe, where it came from, what's the best explanation we have as to where it's going, that's why I wanted to talk about the end of the universe, because I did have sort of an insight earlier today, and I wanted to make it a little personal with you, Kyle. I want to get there in a little while, but I kind of thought, well, maybe what we should do is at least repeat what the possibilities are to begin with. The stuff that you can see on just about any YouTube channel or a brief tour through Wikipedia. So I don't want to bore your listeners, you know, by talking about things that they can easily find themselves.
Well, hey, we're bringing it to them. That's what the show's all about, you know. We're bringing information straight to the viewers so they don't have to go look it up, you know. That's the whole point of TV.
That's exactly right. Well, and to pick up on where you began this, or why is this important or anything, or that we don't seem to have any answers. The first idea, I'll cover them briefly. The first idea is the theory of cosmic uncertainty, Kyle. Do you have any idea what that might be?
I don't really. That could be anything, you know. It's kind of left open.
It's the one that we just talked about, and that's, we really don't know.
But I mean, how is that a theory? What does it answer? You know, like most theories, like, you know, string theory describes how strings work, which describes atoms and particles. You know, you build your way up. Uncertainty theory describes we can never be certain?
We can't know. And I think there was a physicist, no, it was a mathematician and physicist, Henri Poincaré, a French mathematician, who apparently won a prize in the 1800s because somebody wanted to call for a prize to see if anybody can answer this question, how will the universe end and can we know it? He won the prize, and his prize demonstrated that it would require an infinite amount of computing ability for us to ever answer that question. Therefore, there's no way of knowing, Kyle.
You know, when they, you know, I'm sure we're going to talk about the Big Bang and other theories when we get through here, but, you know, a lot of they come down to is that, you know, you can't get any information from the Big Bang before it happened, you know, because we're products of it happening.
Right.
Yep. We can get all the, you know, initial conditions, but, you know, what happened before that, we can have no clue about.
Right. Can't have any clues, so we're going to try to look forward.
So do I get a prize now? I mean, I kind of answered the same thing.
Yeah, that's what I think you did. Well, in the second, so you mentioned the Big Bang, right? The second idea is that at some point we'll run out of fuel, and this is the big crunch. So if there's so much gravity, imagine that the Big Bang started, and we have this gigantic, whatever it is, universe, and at some point gravity will turn in on itself, and we'll end up with a big crunch. There's theory number 2.
Okay, so that is like the Big Bang and Big Crunch. Are they kind of like the same thing, or there's like 2 different theories?
Right, I would say, well, the big crunch, if we're talking about the end of the universe, the theory of cosmic uncertainty is whose guess, and you could have come up with that one, I suppose. Yeah. Second one is, this is going to end in a big crunch and nothingness from there. The third is better known as the Big Bounce. And so I like the way physicists talk about Like there's a period when we were heavily bombarded by meteorites, and physicists will call that like the theory of the period of heavy bombardment. That's a really clever, creative way.
Is that like a scientific, you're expecting like what, like a Latin name or something for it?
Right, some real complex thing that we can't understand. So I do appreciate that physicists will say things like the Big Bounce, which basically means either one of two possibilities. Either after the Big Crunch, it'll bounce back and we'll get another universe going, sort of a cyclic universe, or the one that we're in right now is the result of we're being bounced from a previous sequential universe that already did its big crunch.
Yeah.
And so now we're bouncing back. The fourth one, can I tell you about this one, Kyle? Please.
Yes.
False vacuum. The theory of false vacuum has to do with what physicists discovered about the Higgs field or the Higgs boson, which, as best I can understand it, has to do with how particles get their matter from the Higgs field. And this one, as best I can try to understand it, it reminds me more of how we inhale and exhale. There's this uncertainty and it's chaotic. The universe is expanding. Then, depending on how much dark energy, dark matter there is in combination, then it's going to come in and out at various different types based on the unpredictability of the Higgs field.
Now, that kind of reminds me of the steady state theory that I keep bringing up to you from Fred Hoyle. He talked about that, is that the universe never ends, and that was kind of what Einstein also alluded to it a little bit, but, it's hard to endorse something like that, but that the universe is just kind of just exists, and they didn't want it to either collapse or, they didn't want any of the other theories, basically.
Right. And at this point, all of those that I just mentioned to you have pretty much been discarded. People are trying to, not that science is a consensus, right, but those have pretty much been discarded based on the evidence that we have is likely two possibilities. The Big Freeze or the Big Rip.
Oh,
the
really?
Big Freeze, as you just might imagine, that the universe is expanding and it's accelerating in its expansion, and at some point things are going to get so far apart, black holes will finally dissipate all their Hawking radiation, and we're going to end up with basically heat death. There will be no heat anymore. Yeah,
it comes from, I think, Newton's second law, the thermodynamics, where heat just continually expands. So as the universe expands, it's just going to keep going until there's nothing's connected with anything anymore.
Nothing anymore. Utter heat death. Between
that and the Big Crunch, as far as I know, those have been the two big main theories, that they usually teach. Is either the universe is going to collapse or just going to expand, forever. So.
Right. It's been one of those two possibilities. Well, and the last one is the Big Rip. And the idea behind the Big Rip is that it goes along with the Big Freeze, but at some point, if it keeps accelerating in its expansion, even faster and faster and faster, at some point, every particle is going to rip apart from itself, and we wouldn't have so much a Big Freeze as we would have just a total obliteration.
Interesting. Well, I mean, the particles would still be there, right?
Apparently not. That would be the consequence of the Big Rip.
So it's like, okay, so the universe is expanding, but it's increasing its speed, and it never will stop. So it just increases until we hit like the speed of light or something.
Yes, right. Okay. So, and if we think of, you mentioned Einstein earlier, and so Einstein, as I understand the idea, he came up with the idea of what's called a lambda or a cosmological constant. And back before we knew that the universe was expanding, everybody believed that it was infinite, but neither expanding nor contracting. It was just a flat state, the steady state.
Steady state, yeah.
The one that you mentioned. And so...
Which I don't know if that's up to date on terms, these terms come and go, but, from what I learned, back in the past, that was what everybody used.
I will totally go along with you there. And so what Edwin Hubble then decided, the Hubble Space Telescope.
Is he a famous guy?
He's a famous guy, right?
Okay.
So he discovers that the universe is expanding. In fact, Einstein, sorry, you're wrong, the universe is expanding, so Einstein had to take away his lambda, his cosmological constant, and called it the biggest blunder of his career.
Yeah.
And so After his big blunder, then 90 years passes, 80 years pass, and up into the 1990s, we then discover that the universe is not only expanding, but it's accelerating in its expansion.
So that's giving credit to that Big Rip theory.
Right. And so right now we're at a point where there's certain questions that physicists that they think need to be answered in order for us to find out what the end of the universe will look like. And so to make this personal, Kyle,
oh, man.
I don't remember the name of your car, but it was Big Blue or
Old
it was
Blue.
Old Blue.
Old
Okay.
Blue.
So I'm imagining that you're driving to, let's pick a city out random like Norfolk, Nebraska.
Yeah, city at random. Certainly has nothing to do with me or anything.
And I don't know if I pronounced it right. Norfolk.
Yeah, well, whatever. You know.
I imagine it has to refer to northern folk or northern people or something.
There's a
like
whole
that.
history behind it that people talk about, and it's not really that interesting. You don't really get anywhere with it, so it's like.
So the idea is, say we're in the studio here at KPAO Studios in Omaha, Nebraska, under the shining star of the Satellite Motel just down the road. You're interested in going to Norfolk, so you stop and ask someone for directions. You've got Old Blue with you, and you're asking for directions to Norfolk.
Mm-hmm.
Now I know what would not be helpful for you is to ask, well, where did you come from, Kyle?
Yeah, not really.
That wouldn't be very helpful. If you ask me, how do I get to Norfolk, it wouldn't be helpful for me to ask, well, where are you coming from? That doesn't really make any sense, right?
No.
And so if you think of how do I get there, the two questions that are going to make the most difference, and not only do I want to know your destination, say Norfolk, but what are you driving? You're driving Old Blue,
mm-hmm.
right? And the second question would be, how much gas you got? Fair enough?
Yeah.
How much gas you got, how are your tires in good shape and the rest of it. And so the best I've been able to, this is where I need your help, Kyle, because I just had this idea after 10 days of thinking about this to try to relate it to something we can all sort of understand. The two questions that physicists say will really answer what we need to know in terms of the end of the universe. The first is the current shape of the universe.
Mm-hmm.
And the second has to do with kind of a three-part question. Is it expanding? Well, we know the answer to that.
There's really four things that we got to know.
Yeah, but the second question has to do with the energy.
Okay.
And so I think it has to do with the gas in Old Blue. So the first is, what kind of shape is Old Blue in?
Mm-hmm.
And the second
Not
is
good shape.
all about the gas. And I know Old Blue had to have its own heat death and big freeze, and Old Blue's gone now, but
Yeah.
I'm sorry about that.
Yeah, I miss it.
I did. I wanted this to get personal, but I guess I didn't mean for it to get that personal. I know how much you.
Okay, so what were the three parts again?
So shape of the universe. What kind of shape is Old Blue in? Is Old Blue in any good shape? And the second has to do with Old Blue's gas. What kind of energy Old Blue has to go with? And so these are the same questions really that physicists are telling us we need to have answers to when it comes to the end of the universe. What is the shape of our universe? What kind of shape are we in?
Yeah.
And the second part has to do with what kind of energy is available or put into the system to keep Old Blue on the road.
Yeah, what's expanding the universe, in other words.
Yeah, what's expanding it. And so if we think of the shape of the universe as the lambda cosmological constant that Einstein came up with, that was his biggest blunder but has now been reintroduced, then we're looking at one of the photos that's on there, and I'm going to go out of order, but the one is photo number 3. If you're able to find that, perfect. So these apparently are the three options available to us. Lambda omega is what it's called. So if there's kind of more matter than there is energy going against it, we're going to end up with what's called a closed universe. It'll collapse on itself. This is the big crunch.
So the top one then?
The sphere, right. The sphere is what it looks like. So that's if the cosmological constant is greater than 1. The second one is the saddle-shaped one is if the cosmological constant is less than 1. We call that an open universe. So sort of continuing in its expansion that way, continuing the acceleration, but to the point where it really overtakes gravity.
Okay.
And then the last one, believe it or not, that's the shape most physicists think our universe is right now. It's flat.
Oh, the flat earthers, huh?
Right. Yeah, yes. I thought we might bring up the flat earthers here at some point in this conversation. So really, it's basically about equivalent to 1. And so this was actually what Einstein's first idea is. It's infinite, and but it's basically flat. So this sort of steady state idea. Yeah. Kind of confusing.
I still kind of think that, I don't know, maybe that's just how we, think of the universe. Everybody before has been thinking about it that way, so that we continue. But I feel like if I was going to look at the universe, I'd want it to look like that,
The flat?
Yeah, flat. Well, yeah, everything's just steady, throughout the universe. I know the depiction probably doesn't, give credibility to how what we're trying to describe, but, the universe isn't actually flat, but how you described it with gravity and expanding energy, yeah, let's conform, basically.
Yep, so if we go back to Old Blue, and we think about on the road to Norfolk, and it's flat, like Nebraska often is, so we're going to find out how much gas you got. Well, we figured out that there is gas, this kind of unending supply of gas.
The dark energy?
Which they call dark energy, anti-gravity force that's forcing the universe to expand.
Yeah.
And so imagine Old Blue, your tank is never empty, Kyle. You don't even have to stop off and pay for a fill up. It's just like the gas keeps going.
Yeah.
It keeps in there with you. So how much dark energy is the answer to the question that physicists think we need an answer to determine the ultimate fate of the universe, whether it's one of those options.
One of the main reasons it's called dark energy is because we just don't know what it is.
Exactly. What a creative answer.
It makes up so much % of the universe. We should know what that is, observing so much of the universe.
Right, and if you look at, there's another slide here I brought along with me, Kyle, that I wanted to show you, and this one is number 2 that describes dark matter and dark energy. And so the top part of that, let me start with the bottom. So the bottom part of that pie chart talks about at 13.7 billion years ago, plus or minus, this is right around the time of the cosmic microwave background. And so this, if you look at that, what do we got? 12% atoms, 15% photons, 10% neutrinos, and dark matter. So we got no dark energy, right?
Okay.
Now the top part of that says, so today, atoms actually only make up 4.9% of the matter in our universe, and dark matter now makes up 26%, so it's gone down, but look at dark energy. We've got like 68.3%. This is from NASA, and so now is what we have is all this dark energy coming from everywhere.
And we just don't know where it's coming from.
Don't know where it's coming from.
It's there, we can measure it, but we don't know what it is. So.
Right, so that leads us to believe not only do we have this endless supply of fuel, but since it's accelerating in its expansion, it's like the trip to Norfolk is all downhill.
Mm-hmm. You got the wind to your back.
Yeah, we got the wind to our back. Somehow the accelerator is being pressed, or you're getting better mileage, basically, and you don't know why we're getting better mileage. Are you with me on this metaphor here?
Yeah, I think it's working out pretty well.
I'm trying to work this out, and I think you can help me kind of figure out what this all means. So, right, the universe is flat, it's accelerating in its expansion, and so that leads us really to a flat universe, an open road with more fuel filling up our tank all the time. The last question that physicists think we need to answer, though, remains, well, how are we going to know how much dark energy there will be billions of years from now?
Oh, yeah. So you want to measure kind of from the beginning to where we are now, and then from now kind of predict where we're going to be in the future.
Right, because it looks like from no dark energy to all this dark energy, if it keeps going that direction, we're looking like a big freeze or a big rip.
Mm-hmm.
Yeah. But if it slows down, well, then that'd lend theory to that false vacuum that somehow it's kind of moving up and around. So do we really have an answer to what would happen to dark energy billions of years from now? What's your guess, Kyle? Because this is where I got stuck. I don't know where to go to from here.
Well, it seems apparent that, from the beginning of the universe to where we are now, you see universe expansion. There seems to be energy coming from somewhere that we don't know. They've also looked at, how particles kind of come into existence and then disappear at the same time.
Right, right.
So that may lend, maybe there's a kind of, I study a little bit for that solid state, just kind of trying to understand it. And it kind of states that there's something, before the universe was created. There's some kind of material, I don't know what you would call it, but you just say that there's something there.
Yeah, actually there was the number 5 WMAP slide that I brought along with me.
I already got another one.
So, right, that one's the Wilson I don't remember what it's called, but this is the,
This is the aftermath of the Big Bang.
Right, so this is what they're telling us is 360,000 years after the Big Bang. We can't see any further back than that, but down to 10 to the minus 60 some seconds, this is what it looked like. Now that looks clumpy to me. Doesn't it look clumpy to you, Kyle?
Yeah, a lot of people don't understand why it wouldn't be, more uniform. You'd think from a big expansion.
Because that's what confused me for a while, because they're saying that is almost complete uniformity.
They're saying that's uniform.
That is right. And I say it looks clumpy to me, and so it looks like complete uniformity to me. But if you take their word for it, I guess, and say that, okay, those are the quantum fluctuations.
Okay, yeah. So what they're saying, I can see it from that one, is the deficits and where we have excess at, in the whole thing, it balances out, I'm thinking.
Right, balances out, and so we can't see past it. And so really they're looking at, well, there's that one other slide I wanted to show you, the number 4 there, if you can find it.
We got a whole lecture planned for our viewers today.
Yeah, that one. So this is the one that's most popular you'll see online. You see that cosmic microwave background, that disk that's way over to the left of that image? Mm-hmm. So that is 360,000 years roughly after the Big Bang, which is the bright white dot. And then they described there was an accelerating expansion up until the point that the cosmic microwave background, that disk is, with all those quantum fluctuations. They're saying that's what it looked like. We can't see past it. And since then, you see kind of this accelerating expansion. That tube is just going to get larger and larger and larger. And that's why they're looking at that as being sort of the heat death or the big freeze. And depending on how much dark energy is there, then it's going to all
So either the big freeze or the big rip is what they're kind of predicting with that one.
Right. And so I'm really challenging the guys back in the booth there, but there's one more. The number 1 CCC image that I brought along. So this one is my favorite. I like this one because I don't like it as much as the multiverse theory.
Yes.
The multiverse theory says those quantum fluctuations, as best I can tell, are due to what happened during that period of inflation. And that's whole big inflation is when we have every possible universe came about, and the ones that didn't make it and weren't stable enough or collapsed in on themselves were kind of done for. And this one here is actually called Conformal Cyclic Cosmology. So imagine with me here, Kyle.
Conformal Cyclic Cosmology.
Yeah, or CCC. Conformal, it's describing geometry. Cyclic, because those are successive universes, Kyle.
Going
cycles. If you imagine time is moving up the screen, so towards. So if you look at us being sort of halfway through the middle of the second one there, those quantum fluctuations are due to a previous big freeze or heat death from the previous universe. This isn't a bounce, because it's not bouncing back and forth. It's like successive universes, one after the other. And the only explanation I can gather, Kyle, is that the point at which there was supreme heat at each beginning of those big bangs, And it's the same state as the end, because in the end, in a big freeze, there would be perfect thermal equilibrium. Like there's no temperature if it's supremely infinitely hot or supremely infinitely cold. The Big Bang is the same state as the big freeze. You with me there?
Tough to wrap your mind around that one.
Right. Now that one's my favorite. I really kind of like that one. I know it doesn't answer the questions I mentioned at the beginning, why my interest in philosophy, but with that one, or if it's any other one, we still don't have an answer to where did all that really come from, the origin. We don't really know.
It's almost as if like all the dark energy in the universe all of a sudden disappears, and then it somehow pulls everything back to the beginning at that one moment.
Yeah, yeah.
But you know, there's the question of like, why would it do that? You know, and
right. And so why is sort of the meaning question. So if the origin and destiny are either all wrapped up into the same thing, why even bother? Why even bother is a really good question.
Yeah.
And so that's sort of an origin question, we have a destiny question, we have a meaning question, and then we also have kind of a moral question. So what in the world are we supposed to be doing here anyway?
Yeah, I don't know what we can do with the meaning question much with all of this.
Or the morality question.
Yeah.
Is it as simple as it's not the destination here, it's the journey on the way,
journey.
Right?
That's our quote, right?
So I don't know where you're going with Big Blue here, Kyle,
journey.
but I appreciate you listening to me think of.
Yeah, I'm sure everybody, all our viewers will also be appreciating that. You know, you're always known as the smart guy on here because of the language you use.
Thank you very much. I really appreciate that.
But anyways, I wanted to bring our show to the close. You know, our universe is ending, show is ending, and so I want to thank our viewers. Make sure to follow us on Facebook, and I'll see everybody next week.